Hi, welcome to the new session on SAS, which will be focused on procedures or what we call as PROCs. So procedures are integrated solutioning which SAS provides you so that you just have to pass the data within SAS with very few commands and you will get an analytical output out of that. When you're running a PROC, you will be actually running at max 2, 3, or 4 lines in your procedure, but at the back, SAS will be running hundreds lines of code to give you the output in your desired format. There are multiple or most important procedures or PROCs that we use on day-to-day basis in data analytics or in data sciences. We have listed them down here and we will study them in detail using our SAS editor window. This table tells you what is the objective of different PROCs. For example, why PROC contents is used. So it is used to list the contents of a particular SAS data set, which you will be passing through the procedure, and it will print the directory of the SAS library or that particular SAS data set. So it will give you what is the content of that particular data set saved in a particular SAS library. Then we have PROC print, which will just print the set of observations that you have in your data set. PROC data sets is used to manage SAS files. For example, you have to do some deletions, additions, etc. For that purpose, you use PROC datasets. Format is used to define formats and in format for variables, not much used. So we probably can skip that as well. PROC sort is more like ordering your data with respect to one particular variable or more than one variable. Then we have a PROC frequency, which will tell you the count and frequencies of particular variables in your data. Similarly, we have so many PROCs. I think it would be better if we go to the SAS window right now and see how these PROCs work in the real scenario. So I'm on the SAS window right now. I hope you can see it. Is my SAS window visible now?
Yes, I can
All
see.
right. Okay, thank you. So first of all, we'll create a sample data set, which we are calling as test1. We will be creating that in work library. It has 4 variables: account number, transaction date, transaction code, and amount. And against that, we have a card statement. Again, we can use data lines also. So we'll just simply run this data set. Okay, my SAS is working a bit slow today. So we have a data set test1 created in the work library. Let's create another data set test2, which has variables: account number, store, subdivision, district, and region. And using these two data sets, I'm creating a new data set, sales one. I'm using a merge statement here. We will be covering that in our next session. So just to understand, what I'm doing is I'm combining these two data sets together on the basis of one common variable. We should be just focused right now on the final data set to get created now. So we have a data set created called sales one. Let's see how it looks like. SAS is really, really slow today. Okay. So this is how my data set is. It has an account number, transaction date, transaction code, amount, store, subdivision, district, and region. And we have 21 rows of data. Let me close this data set. Okay. So the first proc is proc contents. Using proc contents, we will display the inside information of the data. So we have seen what are the variables. Now, let's see what proc contents give. So this is the standard output of proc contents. Whenever you will run a procedure or proc contents, it will tell you the intrinsic details of that particular data set. For example, what is the exact name, including the library name, how many observations, variables, when was it created, when was it last modified, and what are the different variables which are existing in the data. So if you see right now, these variables are arranged in alphabetical order. If you want to see the variables in the order in which they are existing in the data set, you just have to add another word var num, and if you run it now, you will see the order of the variables is exactly the same it was appearing in our data set. So most of the time it's advised to use a var num option when you're using proc contents. Okay. Additionally, it tells you the type of each variable, whether it's a character variable, whether it's a numeric variable, and it also tells you the length of that variable. So when you're working on multiple variables, it becomes very important sometimes to know the length of the data set as well, or that particular variable in the data set, because that will define how big your data set is. And in case sometimes in case it's required, you can use some format or informat statements as well to change the length of the variable. Next proc to discuss would be the proc print. So the very basic code, proc print data equal to sales one semicolon run semicolon, is used to print the data as it is. So when I'm running the proc print, it is just giving me or just displaying the data as it is. Okay. So I had 21 observations, so it is also showing me 21 observations. Now, if I want to pull out information on the basis of particular conditions, then we can also use proc sort. So using this proc sort, I'm printing the all variables and sales and totals by region. So this is all variables I'm printing by region. So let's see this output. And yes, I'm creating a new data set as well, sales 2 here. Let's see what sales 2 does. So this is the output, sales 2, and let's see the sales 1. So if you see here, what we have done is we have simply sorted the data by region first. So here what we are doing is we are first, sorry, this is the PROC sort. So we are sorting the data by region. So if we see the data set sales 2, it is sorted by variable region. Let me close this data set now. And on this sorted data set, I am printing by region the sum of amount. Okay. So if you see here, what SAS has done it by different regions. It has given you the data. So for the region Midwest, these many observations are there. For region South, these many observations are there. For region Southwest and West, it has given you the summation of the amount. Okay. So mostly we don't use these options. They are just shown to you so that in case you need, you can use them. But most of the time, because your data set is pretty huge, so you won't be requiring to use this prompt fit option much. Then if you want to limit your observations and variables, so here you are limiting by taking the output of only one particular region and only pulling two variables, you can use this option as well. Now, then PROC sort. So what PROC sort does is, as we have seen earlier, it will sort your data set with respect to these two variables. So first it will do sorting with respect to account number, then it will do sorting with respect to transaction date. Let's run it and see the data set created sales 2. So what will happen here is it will overwrite the earlier sales 2 data set that we created in above step. Okay, let's check the log as well. There is no issue in the log. Okay, so it has first sorted by account number and then transaction date. So this is my account number which is sorted. Then it is sorted the data with respect to transaction date. Because first sorting is done on the basis of account number, so you will, independently won't see the transaction date being sorted exactly in a lowest to highest manner or ascending order, because account number has been sorted first. It is similar way like it works in Excel when you're sorting the data with respect to two variables or two columns or three columns. The same way it works here. Now, if you specifically define that you want to sort it with respect to descending order, you can use the word descending and with these two variables. So by default, we saw it sorted in an ascending order. Now we want to do in descending order. So we can do this, just write descending here. Now this data set will again be overwritten, and you see the highest account number is at the top and then lowest is at the bottom. Now, if you see here in our data set sales 2, There are repetitive account numbers with respect to transaction date as well. For example, if you see this, row number 2 and 3 are getting repeated in terms of account number and transaction date. Row number 5 and 6 are getting repeated in terms of account number and transaction date. So let's say our objective is to delete the replicative account with respect to account number and transaction date. So if you see here, if you combine variable 1 and variable 2, there will not be any duplicate. So the combination of var1 and var2 would be unique here. Okay, you can see here. Now let's say if I want to delete all the duplicate accounts and just want to keep the first account number which is occurring. So I will just pass the variable account number. Let's say I'm creating a dataset sales 3. And if you see here now, account numbers are all unique. But obviously we have lost a lot of information. So in the real world, we cannot just delete this with respect to only account number. What we use here is option is no dupe. So what no dupe does is with respect to all variables, or maybe you don't need to use this option as well, or you can write the names of all variables. It will delete all the duplicate observations in your data. So there will not be any duplicate observations. So SAS will look by each and every variable, and wherever all variables are same, it will just delete those rows, duplicate rows. Okay, now let's come to PROC data sets. So as we studied earlier, or we just looked in our it is to manage SAS files. Now for this, what I'm doing is I'm defining a new library as well. So this is a standard syntax for defining a library. So when I say defining a library, this is a physical location on my system, and I'm naming it a pointer called mylib. So whatever work I'll be doing here will be saved at this particular location, and mylib or lib is a library name which will act as a pointer to this location. Let me define this library. So if you see here, a new library mylib is defined. Okay. So already there are 3 data sets here. What I can probably do is, so I am creating one data set which is named as initial underscore CL. It will override the data set which is already existing. So it has created or overwritten the earlier existing data set, initial underscore CL or credit limit. Then I have a new data set called new underscore CL, which is new credit limit. It contains account and credit limit again. Okay, now let's do this thing one by one. The line 1 says we are specifying the library to list the detail, file names and attributes. So in this library, PROC datasets mylib details will be saved So it is actually not, it is telling me that the details of that particular library. So what is the name of the library? What are the existing data sets in that? Now let's consider the second line. So if I want to change the variable name in the existing data set, okay. Oh, sorry, I want to change the name of the data set. So what I'm trying to do is I'm trying to change the data set name new underscore CL to brand underscore new underscore CL. I can use this change statement. So let me run this. So now if I go to my library, the new underscore CL data set is not seen, but I can see the data set brand underscore new underscore CL. So it is the same data set, just renamed. Most important function of PROC dataset which is used is to delete. So in case we have a library where we have multiple data sets and we have to delete those data sets, we can use this statement PROC datasets delete. Let's run this. Let's go to the log. It says it is deleting the dataset initial underscore CS. So if I see here in the library mylib, I don't see the dataset initial underscore CS. Now, here, what I'm trying to do is from mylib library, I am copying this data set into the work library. So copy in mylib out equal to work. It will copy the data set from mylib library and copy it out in work library. And which data set? This one. Select brand new underscore CL. So if I go to my work library, it has the data set brand underscore new underscore CL as well. So this is how I can copy the dataset from one location to another location using PROC dataset. Okay. Now, one of the most important procedures of PROC is PROC means, or PROC summary can also be used. There is a very slight difference between both of these. We will see that. The dataset which will be used is sales one, and let's see what is there in sales one dataset. So I have this data which has variables account number, transaction date, code, amount, store, subdivision, district, and region. We'll be using the procedure on this dataset. Let's see what a simple PROC means procedure does. Okay. All right. I think it has run. So PROC means has run 21 observation rate from data, and this is the output. So what it has done is it has automatically taken only the numeric variables. So you remember from the previous discussion just 10 minutes back when we were studying PROC contents, it was telling you which data is a character variable, which data is a numeric variable. What PROC means does is it goes into the data, automatically skims out the variables which are numeric in nature, and by default, it will give you number of observations, mean, standard deviation, minimum and maximum of that variable. These are standard things which are defined or predefined when you're not telling PROC means that which statistics you want to see. They will by default give you mean, standard deviation, minimum and maximum. So this is an interview question which sometimes is asked in the interview, that what are the default statistics given by PROC means. So the answer is number of observations, mean, standard deviation, min and max. Now, in case I want to define or tell SAS which specific statistics I want to see. So here I want to see the number of observation, number of missing observations, and miss, the sum or total, and mean for this particular variable amount. So when I run this, for this particular variable amount, it has given me number of observation. If there are any missing observations, so there are no missing observations. What is the total and what is the mean or average of that particular variable in my data. Now, if I want to segregate the information by any character variable, okay, so we will use that. So first we will sort the data by that particular variable or character variable. And then I will run PROC means I seek number of observations, number of missing observations, sum and mean by region and for variable amount. So it has given me 4 outputs. This is for my Midwest region. So if you see here and come see the code again, I have segregated it by region. So what is my by variable here is region. So by region, it is giving me the statistical measures for the variable amount in the separate blocks. So this is for the region Midwest, how many number of observations are there, what is the missing, what is sum and mean, and similarly for other regions as well. Now, let's replace by here with class and let's see the output. Don't you think this output is more readable? So what we can do is, rather than using the by statement, we can use the word or statement class as well. What it will do is it will just create one output box for you where all information will be listed together. So in the real time when you're working on data, always use class statement, because it will create a box like this and you can do your direct analysis. Let's assume that in this region, let's say we were having 10 or 15 variables. So the by statement will create 10 or 15 different boxes, but this class statement will give you information in one box which is segregated by different rows. Now, what I want is statistics for each region in a individual data file. So I am using the output out statement here as well. So let's see the data set sum1. So what I have done is I have taken the data out in a different data set and I have given it SAS a command that I want to calculate this number in terms of amount and sum. So if you see here, so when I say numbers, this is actually how many values are there for that particular region and what is their total amount. So this is how we can just save the output in a different SAS dataset. Sometimes we require it, sometimes we are okay with this output window, and what we can do is we can just copy this and paste it in an Excel, and we have all our analysis in one single Excel file. Okay. So the next PROC is PROC free or PROC frequency. The data set we are using here is sales 1. Let's say we want a unidimensional output only with respect to the variable or table district. So first of all, let's see what's there in my sales 1 again. Okay, so I'm using this data which has account number, transaction date, transaction code, amount, store, subdivision, district, and region. This is the same data set which we were using earlier. And the second last variable is my district variable. Remember to close the data set after you open it. Okay. So what I've done is I have given it statement called table district. So by this variable district, what it has done is it has segregated it into distinct values of district. How many times these individual districts are appearing in my data? So for example, Alaska would be appearing only once, Arizona is appearing twice, Arkansas is appearing twice again. If you sum this up, this total frequency would be equal to 21. Okay. Then by default, it calculates the percentage, cumulative percentage, and cumulative frequencies as well. Okay. Now let's say I want to create a two-dimensional table, district by region. So I will write district star region after the table. Run this. So it has created a two-way table. On the left side, I can see my districts, and on the right side, I can see my region. And these individual values are in the same order as you can see on the top left: frequency, percentages, row percentages, and column percentages. Okay, so Alaska is lying in this west only. Okay, it is appearing once in the west region. What is the percentage, row percentage, and column percentage? Okay. So this is the data where you know the district cross region is appearing once only. There can be a case where let's say this variable on the left side is appearing in 2 or 3 of these boxes. So similarly, or in the similar way, these boxes will also get populated, and then obviously this row percentage and column percentage will get distributed between those two as well. Okay. Now I want only, let's say I want only frequency counts. I don't need that percentage thing. I don't want to get confused, or maybe that is a too much information which I need. So it is just given me frequency. Okay. So if you see here at the top, earlier we had percentage, row percentage, and column percentage as well, but I don't need that. I just need the frequency or the number of the times of occurrence. So I can just pass this statement and it will give me the result. This part is not so important, so I'll take a skip. PROC summary. So let's see. I am creating PROC summary here with the dataset sales one. The class which I'm passing is region, district, and store, and the variable is amount. I'm calculating sum. Let's see. So by different region, district, and store, it has given you the output. So what is the total amount? What is the type? And what is the frequency? This is the store code. Okay. There is another option which is called N-way. Let's see the difference in the output with this N-way option. So what you can see here is the table which I'm seeing here is much more clearer, and it is giving me more relevant information. So most it's very important most of the time to use the N-way option, because this output is not much readable, and it's not giving you the required information, and it might confuse you as well. So we may not be able to interpret it in 100% perfect way. So it's better to use, or it's always advisable to use the N-way option, so that you can have a meaningful output for your precision sciences project. Okay. Then we have PROC import and PROC export as well. I will not be running this particular PROCs here, but you can see the syntax here. So in case I want to import an individual data file from a location, so what I can do is I can give a complete path followed by the file name. Then DBMS is equal to DBMS name. So if it is an Excel file, we have to define the DBMS accordingly. If it is a CSV file, we have to define the DBMS as CSV. Okay. And then I'm saving it in this particular dataset name. So I can write the dataset name. So what I'm doing here is I'm importing an existing file in my system or in Teradata into the SAS environment. Now, if you want to export a file created in SAS or a dataset created in SAS to Excel or CSV file or a comma delimited file, I can use the PROC export data option as well. So I have to write the dataset name. Then what is the particular DBMS name, whether it is Excel, CSV, then the path and the exact file name which I want to place there. So the replace option is used in case that particular file has already been placed there and you want to replace it. In case you don't give the replace option and the file is already existing here, the SAS will throw an error saying that the file already exists with the same name. So we can use the replace option so that the latest version of the file is always saved at the location. Now, one of the most important thing which is used for statistical projects in decision sciences is your PROC rank. So this is how we give a rank to particular variables. And in your predictive analytics for doing logistic regression or any other regression, when we create bins, we usually use the PROC rank procedure. So first of all, for this, let's create a data set called for_rank, which contains three variables: ID, gender, and score. So the data set is created. Now for the variable score, I want to create the rankings in my data set. I created the data set called result. So according to these scores, I have the ranks assigned. So if you see here, this is the lowest score for which the rank is given as 1, and the highest score is 97 for which the rank is given as 20. So this is a simple way how we can define the ranking in the data. Now, the way we usually use in SAS is, let's say, as I said, when you want to make a groups. Okay, so let's say I have 50 millions of rows and I have to divide that into groups of 10, okay, on the basis of ranks on this particular variable score. So this is the standard syntax that we pass. So one more thing to check here is I have removed this word descending in the previous one. So what it has done is it has given the lowest rank to 11. It has given the highest rank to 97. We can reverse that as well using descending option. So depending on your requirement, we can use these options. Now I have created a dataset result. So earlier, since for every ID, I have different scores. It has given 20 ranks to uh, uh, all IDs. Okay, so each ID was given one particular rank. But here, what I have done is I have restricted it to 10 ranks. So all the data needs to be divided into 10 ranks. So let's say I have 100 students in the class and I want to divide it or give them grade on the basis of or grades from 1 to 10. How will I do that? This is how I can do that using SAS. So if you see here, let's do one thing. Our output here is result use PROC sort data equal to result. What I've done is I've sorted the data on the basis of ranking. So if you see here, these IDs are now being sorted on the basis of the ranks. So these two IDs are given rank 0. So by default, the ranking starts from 0 in SAS. You can change that later by doing +1 in terms of variable values. So basically these two, if I divide the whole 20 observations into 10 groups, so these two are given rank 0 or the top is top rank. Then these two fall in rank 1, then rank 2, and so on and so forth. So this is how I can divide the data into deciles as well. Okay. I have divided the data into deciles. So let's say now I want to divide the data into quartiles. So what I can simply do here is I can replace these groups by 4 and take the result out in data new data set result 1. Run this. So this result 1 is created. Now if you see here, all the data is divided into 4 parts on the basis of variable score. So this has a lot of implication when we are doing the regressions where we want to monotonically divide the data and create the bins out of the existing data set. Let's say if we are having the scores or having the probability of default values, and we want to define a deciles or quartiles accordingly. More on that, you can learn on our higher courses on decision sciences, where we covered statistics and predictive analytics. Okay. So, yeah, these are the most important procedures that we use to summarize or pull out some intrinsic information out of the data. Now, I will give you to end a very brief introduction to PROC SQL, which is the SAS implementation of regular SQL, which we will be using somewhere else as well. For example, in PLSQL or in any other version of the SQL or structured query language. But we will cover that SQL in much detail in the next section. So here, whenever we want to write an SQL query in SAS, we have to first write proc SQL semicolon. And after that, our actual SQL query goes. And it has to be ended by quit semicolon. So remember, an SQL or proc SQL has to be ended by quit semicolon and not run semicolon. Now, so let's say I have this dataset sales one. Okay, I want to count the amount of transactions, or some minimum, min, max. All these simple mathematics can be done using my simple proc SQL. Then we have a group by and order by. So I'm just running it here for introduction purposes. I'll be covering that in more detail in future sessions. So what it has done is, by account number, it has given you how many counter transactions are there, what are the total sales, minimum sales and maximum sales. So all this information can also be done using SQL, as the people who already know SQL must be knowing. But yes, this is the SAS implementation of SQL, and you can just start it with PROC SQL and write your regular SQL query after that and end it with quit. It will work in the same way as it works in any other environment where you are writing the structured query language. Okay. All right. So guys, that's it for today. Then we will be covering the SQL and data mergings in our next session. So thanks a lot for attending today's session. Have a great day. Bye-bye.